Hi, it's Lynn. Today's tips and tricks is about exponents. People always have trouble remembering, do I add the exponents or do I multiply the exponents? And I have kind of a simple way, or at least a reference for you to use to get over this. So first of all, the question I ask is, what was the first kind of math you learned? And usually what people say is, oh, adding. So it would be adding and subtracting. And then when you got to like third grade, you got really good at this and it turned into multiplying and dividing. And then when you got really good and you thought you were super cool, it got to be powers. So what happens with exponents is everything with exponents, you go one step back. So if it's a powers problem, like a to the third to the fourth, like that, you would go back and multiply those exponents, so that would be a to the 12th. Then that's a powers example. Multiplication would be, say, a to the third times a to the fourth, and then you go back one to adding, so that would be a to the 7th equals a to the 7th. Okay? Now, if you're adding a to the third plus a to the fourth, there's nothing behind adding. So that means you can't add them, which is right because we can't add like terms. So, and also dividing, if we have a to the fourth divided by a to the second, we go back one and we subtract these exponents. So that would equal a to the second, which is 4 minus 2. Okay, so this is my little hint for remembering. So I'm going to show you an example of how we use that. All right, I'm back with our example. So this is an example of a powers type of a problem and a multiplication problem. So always, if you remember the order of operations, we always will want to take care of the exponents first. So the exponents, what I like to do is I like to put an invisible 1 next to everything that doesn't have an exponent on it, because there really is a 1 there. Also, it helps you remember that it's -3, and I'm going to put parentheses around this for a reason, squared. And then it's going to be a to the 3 times 2, it'd be a to the 6th, b to the 4 times 2, which is 8, and c to the 1 times 2, which is 2. I can put that in parentheses. And then there's no exponent out here, so I can just write a, b squared, c to the -2. Now, I'm going to give myself a little hint, and I'm also going to put a 1 there so I don't forget. All right, so then I just separate everything out. I do all the numbers first, then I go choose a letter. In this case, I would probably start with A because it comes at the beginning. So, and then B and then C, and now all these are multiplication. So one step back from multiplication is addition. So now instead of multiplying the exponents when we have a power, this is all multiplication, so we're going to add the exponents of the like bases. But first we're going to deal with this. What's -3 squared? Well, -3 squared is -3 times -3, which is +9. Now there's a difference between -3 squared and -3 squared. This is +9. The squared only applies to what it's directly next to, in this case the 3, and because there's not parentheses, it doesn't apply to the negative. So this equals -9. So in other words, parentheses are your friend, so you want to use that. All right, so now we're going to look at the a's. I have a to the 6th times a to the 1st. Multiplication, one step back, we add those. And notice that's why we need to remember there's a 1 there. So that will be a to the 7th. Then we have b to the 8th times b to the 2nd. We move back 1, so it's 8 plus 2, or b to the 10th. And then c to the 2, it'd be c squared times c to the -2. 2 minus 2 is 0. Now what happened? What is c to the 0? So c to the 0 means you have anything to the 0 power. Say if I have c squared divided by c squared. which is really what this means. A negative exponent means reciprocal, and it goes into the denominator. So what we do, remember division, we go back one step, and that's subtraction. So that would be c to the 2 minus 2, which is c to the 0. But what's c squared over c squared? Anything over itself is equal to 1. I could have a million over a million, and that would equal 1. So anything over itself, that means that powers are going to be exactly the same. They subtract and become 0. So c to the 0 power is not 0. It's equal to 1. So this can just be replaced by a 1. So it would be 9 a to the 7th b to the 10th times 1, which we don't need to write. So it's just 9 a to the 7th b to the 10th as your final answer. All right, I'm back with example number 2. So this one also has a mixture of something with a power where you would multiply the exponents, but in this case it's division. So we'll start with the numerator, and remember the hints where we write a 1 next to anything. So there's a 2 to the 1 here. So this means this is equal to 2 to the 5th power, because 1 times 5, we multiply the exponents because this is a power. And then the 6 is going to be 6 times 5 because it's a power. So this would be x to the 30th. And then we're going to divide this by, now there's no parentheses here, so we just go negative 16x to the 10th. What's 2 to the 5th? Well, 2 to the 5th is 2 times 2 times 2 times 2 times 2, 5 times, which is 32 x to the 30th over negative 16 x to the 10th. So again, I said we separate things out. We do things one at a time. We're going to do the numbers. 32 divided by negative 16 is not 32 minus 16. Like you would do with the exponents, they're actually numbers. So 32 divided by 16 is actually negative 2. And then you have x to the 30 divided by x to the 10th. Division goes back one step to subtraction. 30 minus 10 is 20, so it's x to the 20th. And that's our final answer. Great.